bring to the original screen. As we can see slide. Others also can see a slide here.
The nickel ore that is on screen.
Yeah, so stop. I think Rahul, stop sharing.
Sir, I am passing the host right to you and leaving, sir. I will join again.
Okay. Jace, can you stop sharing? Is there the option stop sharing at your end?
No, it's not on my
Okay.
end. I
Okay.
don't have the sharing rights.
Okay. Yeah. So I think the screen is okay now for everyone.
Yes, you are in the spotlight.
Yeah. Yes. Good afternoon, everyone. So with the permission of Pahuja sir, can we start the webinar?
Yeah, please.
Okay. Once again, good afternoon to all the panelists and speaker as well as the participants. Before we start the program, let me introduce you to the system WebEx. Some of you may not be aware. You have been given the rights to chat as well as ask question and answers. The chat box is to introduce yourself and Q&A box is to ask question and answers, which you can put and we will take it up in the end. If you are unable to put your questions in Q&A box, then you can use chat box also to ask the questions. To start the yes, okay. So to start the program, which is the educational series, some of you are aware that we have been doing this series for last 5 times, and this is the last part of the series for learning stainless steel from technical experts. Today's series is on right grade selection and development ideas in stainless steel. To start, I'll request our president Sri K.K. Pahuja to give the welcome address.
Thank you, Rohit, and good afternoon to all the delegates and the panelists. On behalf of Indian Stainless Steel Development Association, I welcome you again to this educational series on stainless steel, brought to you in association with Outokumpu. We had a tremendous run in this series with a very exciting response and a very nice feedback from all the participants. So we thank you for making this series a successful, and a great thanks to the Outokumpu team for joining hands and sharing their vast knowledge base, and also to Nickel Institute for supporting this event. Today is the last and the fifth session of the educational series, which is basically going to be focusing on the right grade selection. In addition, we'll also have information of new applications and new grades, which are constantly being evolved and developed in the stainless steel industry, keeping the requirements of the market. And as we have said before, the grade selection is probably one of the most important of stainless steel usage to get the right value for our end users. So with those brief introduction, I hand you back to Rohit for the next leg of the program.
Thank you, sir. Now I would like to invite Mr. Zorg Schweizer, Manager, Nickel Institute, to give introduction about Nickel Institute and program. Zorg.
Okay, thank you. So, Raul, if you can hand over the share function, please. I got it, thank you. And share. So I hope everybody can see now the screen. Yes, I would like to welcome as well everybody to this very interesting event that ISTA is organizing together as well with Outokumpu. And of course, we are supporting it because the nickel content of stainless steel is very important, as you heard in the previous events and webinars. So this is where we definitely support ISTA as well, Outokumpu, to showcase you guys what stainless steel can do. As you all know, nickel is a key element in more than 75% of all stainless steel that is produced, and it delivers outstanding physical and mechanical properties. And that's why stainless steel is such an attractive and easy to use and sustainable solution. The Nickel Institute is a global association from the leading primary nickel producers, and we want to grow and support the markets, and we meaning the market development team of the Nickel Institute. This is where we are located. We have a headquarter in Toronto, Canada. Then we have offices in Washington, the US, our research lab in Durham, US as well. The European center is located in Brussels. Then we have a non-profit organization in China, as well in Japan, and 2 rep offices, one in Singapore and one in Australia. I'm the one that is based in Singapore. These are the primary nickel producers. These are the members that are funding the institute. And at the end, I'm the market development manager for other Asia, meaning all Asia Pacific except for China and Japan. That's it from my side. I'm handing over to a much more interesting topic of today's webinar. And Claes, have fun.
Thank you. Yeah, thanks, Jess. Now I would like to invite Mr. Rajiv Seri, Managing Director, Outokumpu India Private Limited, to introduce the speaker as well as talk about the program.
Thank you, Rohit. So a very good morning to my friends from Europe, and good afternoon to all the people who have joined from India and Asia Pacific region. A very warm welcome to all of you. First of all, it is my duty that we would like to thank ISDA for supporting or collaborating with Outokumpu and Nickel Institute to organize this webinar series where technical experts are speaking about various aspects of stainless steel. So we already had a very good run of our previous session, and today's session is going to be even more exciting because all the knowledge that we have gained, now we are getting into that how we are going to make use of it when we are selecting a suitable grade for a new application or a new process. And personally, I would like to thank Pahuja ji, Rohit, and also Rahul from backend team who are really supporting to make this event very successful. We also would like to thank Nickel Institute for supporting all the effort that stainless steel industry is doing in development of business and new application. And we are always getting necessary support from Nickel Institute whenever it is required. And I also like to thank all the delegates who have been able to join for today's session in very large number in spite of their very busy schedule. And this shows that there is a eagerness, there is a hunger, and there is a need for people to learn more about stainless steel. And from our side, in association with ISDA and Nickel Institute, we will continue to support these kind of initiatives. Today, in our webinar series, we have Mr. Klaas Tigerstan, who is our technical expert for the session today. A very small introduction of Klaas Tigerstan, because now he is a very much known face here in India. But still, for people who have joined only today and they have not attended the pre-session, Mr. Tigerstan, he is having a master's degree in mechanical engineering, and he has experience of more than 20 years in technical marketing of stainless steel. His specialization is particularly in duplex and high strength stainless steel alloys. He has worked in several different managerial positions in Outokumpu, whether it is technical or quality, R&D, sales and marketing. So he has a very vast experience of all the different departments. Currently, Mr. Tiger Stand, he is heading the technical value creation team. So in our company, we have a separate team who provide support to customers for all the technical innovation and new development. He is responsible for heavy industry sector, which is especially focusing on application related to storage tanks, pressure vessels, for chemical process, pulp and paper industry, industry. So he is very useful for all of us. He is based in our uh, Sweden mill, Avesta mill, and we thank him very much for today's session. We also have with us Mr. Deepak Vedia, and Deepak Vedia is a known face in the stainless steel industry in India, but still I'll say a few words about him. So he is a mechanical engineer and a fellow of Institution of Engineers. He has additional qualification in business management and human resource development. He is also a certified business coach from BCC Finland according to ICF norms. He has more than 26 years of experience in different aspect of metal industry with focus with specialization in stainless steel industry. And his focus is always on driving innovations and developing and helping us to support innovation in whatever customers are trying to achieve. Stainless steel. Why material selection is important? Because selecting the right grade is very important for a specific application, because we want to achieve the sustainability and cost effectiveness. And material selection is very important when we are going for new applications or new equipment or new process, or if there is a change in the process, or if we are facing problem with the performance of the existing material, and also very important how to optimize the cost of the raw material. And many of us are aware about grades like 304 and 316, but there is a of what are the options and opportunities available to us. With these words, I give it back to Rohit so that he can officially announce the opening of this webinar. Thank you.
Thank you, Rajiv ji. Now, straight away, I'll request Tiger Stand to come forward and load the presentation. Rahul, give him the rights. Meanwhile, I'll request other panelists to switch off their videos to increase the bandwidth. Let only Clays have the video. Yes, we can see full screen. Go ahead.
Okay, thank you very much for the introduction. And we go right ahead with the presentation now. Right grade selection and new development ideas in stainless steel. Let's start with talking a bit about the importance of material selection. Why do we actually need to bother about that? Of course, selecting the right grade for a specific application is vitally important to achieve both highest sustainability and cost effectiveness. But of course, most obvious first when you need to consider material selection is when you have a new application or you have a new equipment that you are currently developing. You have new processes or changes in your processes. Or you have a poor performance of your existing material solutions. Or you want to minimize the cost or optimize to get the most out of your material to get the best possible performance there. And what is very important here is to create awareness of the different options you have, because there are quite many different types of stainless steel that we already have been talking about in earlier sessions. There are grades beyond the most common stainless steel 304 and 316 to get higher performance or to go leaner, less costly. Considering the material selection criteria, there are a lot of different aspects to consider. First of all, obviously, the corrosion resistance in different environments. The service temperature is very important, which type of stainless steel actually there. Mechanical strength, and of course, with the highest strength, possibly you can go for a weight reduction and use less material. Fabricability and especially weldability. Welding is key here. Structural. After talking about stainless steel, the surface aspects is of great importance, and there also the cleanability, the appearance of the surface. Physical properties, we will touch about that in a few cases, could be very important as well to consider, such as thermal expansion, thermal conductivity, and so on. Availability, obviously, more specialized grade has a lower availability, so that is an aspect to consider as well. The cost, and what we want to emphasize is the total life cycle cost, that you consider all the cost connected to the material over the service life until you recycle the material in the end. So what's very good with stainless steel is that it's fully recyclable. Then another important topic is legalization, standards, and approval, that you actually can use the material for your specific application. And I guess further on you can come up with other important aspects for the material selection, but here you have a few of them. So some environment 304 and 316 are not enough. What we see here is actually atmospheric corrosion testing result in a chloride-bearing marine environment. What we see to the left there is a sample of 316 that is heavily stained, and to the right there we see a duplex grade 2205 with a perfect condition. So it has been exposed in the same harsh environment there, and you see very different result there of the performance. And that is very much connected to the limited resistance to uniform and pitting corrosion in more hostile environment of the 316 compared to the Duplex 2205 in this case. Other properties as well that could be critical is stress corrosion cracking. Typically, the standard austenitic grade 304, 316 are more prone to stress corrosion cracking, whereas Duplex grade and higher alloyed austenitic grade are less prone to stress corrosion cracking. And then finally, mechanical strength. The Duplex grade has a higher mechanical strength than the standard austenitic grade like 316, and that I will come back with a few examples of here. So there are grades beyond 304, 316, and that we can explore within the ultra range we see to the right there. There you have the highest alloyed austenitic grades for harsh environment, or you can go by Duplex grade where you have a good combination of high strength and high corrosion. So shortly about our product portfolio, we have divided our products into two different families. First, we have the classic family where we have Moda, Core, and Supra. I will shortly come back to what that is about. And then we have our specialized grade within our Pro family where we have Ultra, Therma, Forta, Dura, Product, and finally Deco. So within the classic family, we have three different ranges. At the top there, we have Moda.
I think there has been some issue with his internet connection. Let us wait for just 1 or 2 minutes so that he locks in back. Mr. Seri, you have any input from him?
Yeah, Rohit, I'm checking it. Just a minute.
Yeah, sure. Okay. To all the participants, we'll request you to just wait for 2 minutes. He'll be back with his when he gains the internet.
I think there's some technical glitch because I could see that his internet is working, but I sent him a message.
No problem. Sometimes it happens in virtual world, you know. Because we can see that there has been some bandwidth issues and voice was dropping a bit in between. Yep. I think he'll be back in few seconds. Yeah.
Sometime you can see that it has corroded. So you can see these corrosion marks. So it has limited resistance to uniform and pitting corrosion, these 316L grades and 304 grades. And in the similar environment, we have kept this Duplex 2205 material, and you can see that after similar time in the similar environment, the material is too clean. So that is why you have to shift to the high alloyed grades where 304 and 316L are not sufficient. And in high alloyed, we have two families. One is ultra high range alloyed austenitic steels, and one is the Duplex grades. The orange one you see is the ultra high alloyed. This is the austenitic series for extremely corrosive environments. And then you have the Forta Duplex series, which is a optimal combination of the high strength as well as the corrosion resistance. So you have both the series over there. This is the next slide, Autocompo product portfolio. As we started earlier and explained in all our presentation, we have divided the whole stainless steel family into two parts. One is the classic family, starting from the mildly corrosive environments called Moda, then going to corrosive as Core and Supra, which is normally used everywhere. Then we go with the Pro series, which is a professional series, ultra very high alloyed austenitic, as I mentioned. Then Therma, which is a very high temperature where we can produce material to sustain up to 1100 degrees centigrade cyclic temperatures. So there is again a family depending upon the temperature, and you have very high creep strength material. Then you have Forta, Duplex, and other high strength material. And Forta series doesn't only mean that it has Duplex. Even some of the grades like 304, we are able to achieve a very high strength. So we have kept them also under FOTA, that it could be 304, 316, 301, 301 LN. Then if you need the material with a very high hardness, that is a Dura series. And somewhere in the applications, when you need a material with a very good machinability, improved machinability, then some of the grades are being manufactured accordingly to, then the series is called Product. Then we do produce some material with the decorative finishes or surface finishes. It can be a polished or some decorative, some pattern. So that is a deco finish. So that is how we have divided the whole stainless steel family into two parts. And the sole reason to do this was that many times only the manufacturers were aware of all these issues and aspects, which grade to be selected. So now most of you as an end user can select the material to an extent depending upon your application from this series. Okay, this is what I have explained you just now. Just clicking on to Forta series, which you see, you can see the RP02 value. The green one is having a strength of more than 400 megapascal as per the standards. And PREN value, pitting resistance equivalent number, they vary from 16 to 43. 16 starting from in the austenitic series, and when you talk about lean duplex, it is around 24 and 26, then going up to super duplex up to 43. Ultra high alloyed, they are normally having a PREN more than 27, and Therma, when I talked about, is the high temperature, it is more than 550 degrees centigrade. These are the wall charts which are available on Autocompo sites, or you can write to us, we can share, and you will find almost all the details, the grade, its equivalent standard in ASTM or EN, then what is the PRN value, then what is going to be the elongation, the RP02 value, and whether the grade belongs to ferritic family or austenitic, what is the typical composition. Again, same for Dura series, Therma, and Product.
So
And
Deepak,
how we started? Yeah.
can you hear me?
Yes, Rajiv.
Yeah, class is back. So maybe he can continue from here.
Very good. Excellent.
Sorry, can you hear me?
Yes.
Yes, class.
Very sorry, I lost the connection here. Can you see my screen now?
Yes, full screen I can see.
Yes, class. You can say it.
Okay, thank you, Deepak, for continue the presentation there. I don't know where you.
Yeah. Can you go to the slide before?
Yeah, some reason it's locked now. I will just. Yeah, I think you were at this point.
Yeah.
Deepak.
Yes. So this I have completed. You can start
Okay.
slide or next.
Yeah, thank you, Deepak. There. This just shows an overview of the different grades we have within the different product families here, and we call it the wall shot that is possible to download from our. So for technical information is from the Outokumpu website, and there we have a lot of data sheets connected to each product range. We also have our technical handbooks. You have the handbook of stainless steel is the only one, the blue one, the general one that is possible to download in an electronic format. All the other handbooks are actually only available as hard copies. We will mainly focus here on the content of the corrosion handbook in this session. But don't mistrust if you don't have access to those handbook. A lot of the information is actually available online from what we call the Steel Finder that I will showcase here today. So I have only done screenshots from our website here to make sure we actually can follow the content here instead of going live. So up in the right hand top corner there, you have the Steel Finder. So if you click that one, you will enter where you can find some different there. You look more into material selection, properties by products, and if we first click that one, we can find this Steel Finder tool. I briefly showed that in an earlier session there, but basically you can filter there. For instance, if you let's start up the pointer again here. If you want to have a PRE above 30, you want to have a strength about 300 MPa, then it filtered down to the grade that fulfill that criteria. And for instance, if we are interested in the Duplex grade Forta LDX 2404, we can click here and it's possible to download a data sheet for that specific grade. Material selection criteria could differ depending on what type of application and industry we are considering. If we are within the catering and appliances, of course, surface appearance, cleanability are very important, and perhaps corrosion resistance is not so critical, and mechanical strength cannot really be utilized there. On the other hand, if we're talking about the chemical process industry, the surface finish is not so important, but on the other hand, corrosion resistance is very important. And for large vessels, you can, in many cases, also utilize a higher mechanical strength to reduce the material consumption. And if you need further support, then it's available on our website. Of course, you can contact us. Contact our local sales reps, like Deepak with a lot of knowledge, and he can guide you, and we can get further support from our global expert functions as well there for the material selection. Very shortly about standard approvals and regulation. This is an area that is very important for us. We see this as a very important communication tool between the producer and the customer. And of course, the standards are developed in a consensus-based approach where all the stakeholders are included and all views are taken into account. So what type of standards are we working with? Mainly, we are working with European standards because we are a European company, and the American standards, but also the Asian standards are very important there. We have the Japanese standard, the Chinese, and obviously also the Indian standards that we follow and make sure we can fulfill the regulations there to make sure we have the right approvals to sell our products in those countries. And then, of course, we also have the ISO standard, which is a global approach. So we spend quite a lot of time to make sure our grades are included, but also to develop the standard for better utilization of our products. There are a lot of different types of standards. Of course, first you have general standards, talking about the steel designation system, what type of grade number you will get on the different types of grade. You have the material specification, perhaps the most important one. We have the European standard like 100088, or the American counterpart, the ASTM and ASME A480, or the A240, where you have all the specification of chemical composition and mechanical properties and so on. Design standard as well, for instance, pressure vessel standards, storage tank standards, very important as well to make sure you can utilize our materials to the full extent. Then, of course, there are standards related to welding and welding and qualification. And then finally, testing standards for tensile testing, corrosion testing, and also to quality control standard, for instance, the ASTM A923 to detect detrimental phases in duplex stainless steel, a very good tool to make sure you have the right properties of your grade also after fabrication. Let's have a look into a few case studies related to material selection, and we will use our Corrosion Handbook as a tool. Within this handbook, we have 90 years of experience in testing. There's first one part with technical articles, and there's a second part with corrosion tables, and finally a part with physical tables and some more support guidance there. In the technical articles, we actually cover a lot of different areas, material selection into a lot of different industry sectors, like pulp and paper, oil and gas, to make sure you use the right grade and based on our experience there. But if you can access the Corrosion Handbook, I don't think it's only a few of you that has this handbook, but don't mistrust. We have the corrosion tables also online, and I will guide you to that as well. And if you would be interested in some of the technical articles I just showed you here, it would be possible to send electronic copy of one or two of these as well. So let's have a fictitious case here of material selection, and we will try to use a few of these tools in the material selection process. So we consider a storage tank for sulfuric acid here. A client you are discussing with will be bidding for a tank project. they have already made a similar tanks for the same environment in carbon steel, coated with a rubber lining and painting on the outside. The tank will be sited close to the shore in the Mumbai area and will be used for storage of 20% sulfuric acid. The tank height is 50 meter and the diameter is 20 meter. The design temperature is 40 degrees C. Which stainless steel grade could be suitable for this application? And we will mainly consider corrosion resistance and mechanical properties. So, and then finally, which would be the most cost-effective solution? Would it be the stainless steel or the painted carbon steel if we consider not only the material cost, but also fabrication and life cycle cost? And there we also have a tool to assess that part. So, looking at factors influencing the material selection, of course, obviously the environment on the inside, to resist the stored media, that is the most important here. Could be a chemical, could be a water solution. Service temperature is important as well. Typically, when the temperature goes up, the environment becomes more corrosive. Also important to consider is the outside of the tank, because if you are very close to the sea, you can have airborne chloride in the environment that could be equally corrosive as the inside. We talked shortly about standards and approvals, important as well, and also product availability. Looking at very large tanks, the structural behavior is very important as well. Looking for higher mechanical strength, and if we can utilize that, we can actually reduce the thickness and use less material. The fabrication is of course key as well for a large storage tank, especially on the welding. And then of course, coming to the selection, the economy is key. But not only to focus on the material price, but also to look at all different types of costs, to consider the total life cycle cost. Sustainability becomes more and more important now. So also to consider that you're using a recyclable material, and also how much impact in carbon footprint you have to the environment, that is key as well. And then of course, the selection is based on references and experience. So you make sure with a good confidence that you are using a grade that can resist the environment. First, to see if we can actually resist the 20% of sulfuric acid. Then we can consult the corrosion handbook, and we can look at an ISO corrosion diagram for sulfuric acid. What you have here is the temperature of your chemical at the vertical axis, and you have the composition of your sulfuric acid on the horizontal axis. And then you see the performance of different grades in this graph. So if you are on the left side or below the curve, then you're safe. On the right hand side, then you can expect to have corrosion. So the line indicate where you would have, if you are on the left hand side, where you have at more than 0.1% millimeter of corrosion per year, and on the left hand side you are safe there. So considering we have 40 degrees C, 20% sulfuric acid, then you are here just on top of the line for a 316. So you would need to look for a high resistance, and that could be to look at the now it's a quite busy slide here, but if you're looking at the Forta Duplex 2205, then you see the line is here. So then you are on the left hand side here, so you are safe here if we select a Duplex 2205. Okay. In this handbook, you can also look into the table. So you have the isocorrosion diagram, but you can also look into this table. So we consider the same 20% sulfuric acid, 40 degrees C. And what you see here indicated by a figure, if you have a 0 here, it indicates that the corrosion rate is less than 0.1 millimeter per year. So that is what we should look for. A 1 indicates that you have a corrosion rate between 0.1 to 1 millimeter per year, and 2 indicate a corrosion rate above 1 millimeter per year. So what we saw here is actually that the 316, there you can expect some corrosion, whereas on the Duplex 2205, you have a 0 here. So no corrosion or very limited corrosion there. If you don't have access to our corrosion handbook, then you can enter the steel finder on our website. So you go into steel finder, you tap the corrosion table, and you type in sulfuric acid. Then you will get a different type of table that looks like this. You have a similar content that is in the corrosion handbook, but it's slightly different visual appearance here. So you go for the sulfuric acid 20% at 40 degrees C, and you see that the green circle indicate the same as the 0, where you don't expect any corrosion, and there you see for 2205 you have a green circle there. 360 have this yellow circle there. Can we just stop here and see, can you still hear me? So we make sure you can still hear me.
Yes, Clash, we can hear you.
Okay, but I was a bit worried there about the connectivity. Okay, then I continue. So this is available from our website. You can see that for this environment, you would need to go up to a grade like 2205 to resist this environment. Then we go looking on the outside, atmospheric corrosion. This is quite tricky, but we have some guidance here as well. If we consider Mumbai close to the shore, this is a very corrosive environment. It's a tropical environment, high temperature. You have airborne chloride coming from the sea, so you can expect it's a marine environment. We can consider it as highly corrosive. So we are at the very right end here. And to make sure we have good performance here, yeah, we need to look at the highest alloy material. Perhaps 2205 could be a borderline here. Perhaps you need to go all the way up to a super duplex. That needs to be assessed, of course, more in detail, how close you are to the shore, how much you are exposed to the airborne chloride from the sea, and so on, and how well the rain can actually clean the surfaces and so on. There are some other tools maybe you're aware of. The ISO standard, this is typically used for the carbon steel coating system, where you're looking at different corrosion categories. The less corrosive, you have the C1 up to very corrosive, C5, CX. And of course, in an environment close to the shore in Mumbai, we are in a tropical zone close to the sea, and you need to look what you can see to the very right for the highest alloyed material. Perhaps a Duplex 2205 could work, but perhaps you need to go for higher alloyed super duplex to fully resist this environment. If we then continue talking about the strength and the possibility to utilize higher strengths to reduce the material consumption, there we have what's called a storage tank calculator. If you tap that, you can select different design standards for storage tanks. We have the American standard, which I think is more used in India, sorry, that is the API 650. Let's use that. The the European counterpart 14015 as well. We type in our conditions there, temperature, the height and diameter of the tank. Here I think I mixed it up actually, that the height perhaps should be 15 and the diameter 20, but it doesn't matter so much here. But here we are using the height 20, diameter of 15. We type in the density, which for 20% sulfuric acid is 1.14. So then we select the grade we want to compare. We type in the Duplex 2205 in this case, and we also type in the carbon steel that we want to compare to. So let's type in a carbon steel A36, a common standard carbon steel. We are using 2 meter wide. The joint factor, that means that you have a fully non-destructive testing of the welds. You're adding a corrosion allowance of 2 millimeter to the carbon steel. Typically, even though you're coating the carbon steel, you need to add a corrosion allowance for safety. So if the corrosion coating cannot protect the grade any longer, you need to add some extra material there. In this case, we're adding 2 millimeter. You can calculate, and there you see the thickness you need for the different sectional courses of the tank. You have the highest pressure at the bottom. So for the Duplex, you need 7 millimeter at the bottom, 6 millimeter at the top. But for the carbon steel, which has a lower strength, you're adding 2 millimeter of corrosion allowance. There you see you need 30 millimeter at the bottom and 6 millimeter at the top. So you have about 30% saving already in the material consumption by using the Duplex grade. Also on our website, you can see there's a possibility to contact us if you want to have a more thoroughly analysis of welding cost, of coatings, the total life cycle cost. So if you contact us here, then we actually have a more advanced tool where we can do a more detailed analysis of the life cycle cost of the tanks. There we are in grade specification of the tank. We add the material cost, we add the corrosion allowance with welding cost, the life cycle parameters there, and we can do the same, calculate the required thickness for each section of the tank. We can calculate the total life cycle cost for the Duplex, where most of the cost is related to the material, some to the fabrication and the pickling of the welds or cleaning, post-weld cleaning of the welds. Whereas for the carbon steel, the cost of the material is less. However, you have to spend a lot of cost to the rubber coating, and if you need to recoat the carbon steel once during the service life, that adds a lot of cost. So for the total cost, actually the carbon steel tank could be more costly than the stainless steel, even though it's much more expensive from the beginning if we're just looking at the cost per kilo. So this is a tool that we can showcase for you and demonstrate, and you will have a report provided with all the details to the analysis there later on. So that is something you can contact us to do this type of analysis. So considering this case, which could be a suitable grade for this application, considering the inside, a Duplex 2205 will work fine there. Considering the outside, 2205 could be sufficient, but if it's very close to the sea, it could be that you need to go to a super Duplex as well here. Could it be cost effective compared to carbon steel? Yes, it can be there, especially if we consider the total life cycle cost and you consider that you possibly need to recoat the carbon steel tank. You need to have a shutdown, a maintenance break, and you cannot use the tank, and you have to remove the old coating. You need to recoat it. that will add a lot of cost on the total life cycle cost there for the carbon steel solution there. If we continue here with a second case, we consider a water heater cylinder. So a client is offering two different material solution for their water heaters. They use a standard version 304, or they have a premium version using a 316. Their current perception is that the service life of the standard solution from time to time is poor due to corrosion issues in some regions, whereas the premium solution works fine in most cases, whereas the cost is slightly too high. So what can be a good solutions here? Maybe we can look at alternative material selection. What could be the reason that the 304 doesn't work well in some market? That is one question. What alternative solution could we look at here considering corrosion, tank weight, and cost? Are any obstacles if we consider alternative solution? So now we can consult the corrosion handbook as well, and we can look at some engineering diagrams. This is where you have the temperature on the vertical axis. On the horizontal axis, you have the chloride content of a water solution. What is important to note here is not only chlorides there, it's also slightly chlorinated, 1 ppm of chlorination that you typically have in tap water. So same as the ISO corrosion diagram here shows that if you are on the left-hand side of the line, you are safe. If you're on the right-hand side, you can expect pitting corrosion. These graphs are quite conservative, so they also consider that you have a welded design. So it's not only the base material. So for a water heater, let's consider in different markets that the chloride content can vary between 100 ppm and 300 ppm of chlorides. And we'll look at a service temperature of 70 degrees C. So if we go into this graph, we will end up here spanning from 100 ppm of chloride up to 300 ppm of chloride. The left hand and the right hand graph is the same. The difference is on the chloride content range. This is for the lower from 10 to 1000, and the right hand is from 100 to 100,000. So what we see here, considering 100 to 300 ppm of chloride, that if we are at 300 ppm of chloride, we are at the borderline for 316 actually. So in most cases could work fine, but if we're looking at 304, we are actually, if we are at 100 ppm, then we are safe. But if we go above 100, ranging towards 300, 304 would not be sufficient. And at 300, as I said, 316 is at the borderline. Okay, so that is valuable information here. We can also look at the CPT value, corrosion pitting temperature testing, to see which options we have. The performance of 304, the resistance for pitting corrosion, you see it's quite low. It's below 10 degrees C here as the ranking temperature here. So going to 316, you see we improve the performance considerably. So that makes it much better performance. So what other options would we have? We can look at a higher ferritic grade, but that will not be much better than a 304 according to this testing. Which is a leaner version of 316 but alloyed with nitrogen, which performs very well. That can be a good option. Also higher strength here, potentially we can save some weight there. But what we can do as well is go for duplex grade. Lean duplex grade will be a good alternative with a corrosion resistance sitting in between a 304 and a 316. That can be a good option. But what we saw there, 300 ppm, maybe a lean duplex is not enough there. We can have a look at higher alloy duplex grade like the 304 or even the 2205, where we have a much higher resistance. Considering the strength, once again, in the steel finder, we have a pressure vessel calculator. So if we type in 70 degrees C, we type in the dimension of the cylinder. Let's say the diameter is 500 millimeter. You have a design pressure of 10 bar in this case. For the carbon steel, we're using corrosion allowance of 1 millimeter. So then we see, using carbon steel, the thickness would be from 2 to 3 millimeter. Using austenitic grade, a 4316, you would need 2 millimeter. But with the duplex, you can actually reduce it to 1 millimeter potentially. Of course, here you need to consider other things like handling and welding and to handle deformations, but potentially you can reduce thickness a lot here. This is only valid for the European pressure vessel standard. But here I've also done some comparison using the ASME standard with the 304 316. You have a quite low design stress and the thickness will be thicker. So the total weight of the tank would be about 30 kilo, whereas with a duplex you can reduce, so the total weight will be about 20 or up to 22, 23 kilos. So considerable saving. Using a ferritic grade 444, the weight will actually be higher than the austenitic grade. So using the American standard, you cannot really utilize the ferritic grade in a good way. Using the European pressure vessel standard, as we saw from the steel finder, is actually less conservative than using the ASME standard when you're using the Section 8 Division 1. With the European standard, you can reduce a bit further for the austenitic grade, but especially for the duplex, you can reduce the weight considerable there. And also for the ferritic grades, you see you can reduce it quite a lot compared to the austenitic grade using less material. So coming to the conclusion there, one, you have in some markets, means before can suffer from pitting corrosion, so you need to go for higher alloy material. So which alternative you can use there? The most obvious one is to use duplex grade, where you have both higher strength, higher corrosion resistance. So any obstacles to consider with the alternative solution? Obviously, are they included in the relevant material and design standards, pressure vessel standards? That is something you need to consider. Formability of the dished ends. Of course, austenitic grades has a better formability than duplex or ferritic grades. That needs to be considered. Weldability, very thin sections, you need to consider weldability and to follow the welding recommendation there. Of course, battery corrugated vessels, it could be difficult here to use a shielding gas so to get the same corrosion resistance of the weld as for the parent material. So very important to consider that the heat connection that has sufficient resistance also for the weld. Looking at references, availability of course is very important here as well. Finally, we have a case for a stainless steel ship hull. This is not a common application for stainless steel, but there is actually a true case here in Sweden where they're looking at using stainless steel from a professional type of use, like the Coast Guard or rescue vessel or military vessel. And mostly they are designed using painted carbon steel or perhaps using aluminum alloys or even carbon fiber reinforced plastic. So what can we consider here? Seawater is very corrosive, and consider for this type of boat, you want to use a very fuselage of an aircraft using very thin structure, using a very flexible, durable structure. So they want to have a high strength in this to reduce the thickness of material. But first of all, the most critical is, of course, the seawater. We need to resist the seawater. And if we're looking at seawater, let's say we have 30 degrees C, we have a chloride concentration in seawater. Let's say we have about 12,000 ppm of chlorides. Then we just sit on the line for 2205. And if we also consider that seawater is more corrosive than just artificial water with chlorides, because you need for the seawater to consider microbiological activity as well that makes it corrosive. We need to step up from 2205 up to super duplex, or even a 6 moly high alloy austenitic grade like the 254 SMO to resist seawater. So if we're looking at the material selection, high strength, yes, use duplex. To resist seawater, you need to go for super duplex in this case, and that is exactly what this company has done for their first prototype of this type of vessels. If we talk in very complex environment, it could be very difficult just to use our material selection tools available, or let's say use our experience. A best way could be to do a field testing. So that is something we can provide, that you can have a test rack having different types of grade, and you can actually mount it into your environment in your vessel, and we can evaluate which grade are the best for a specific environment. So right type of stainless steel for different applications. As we said, service temperature is very important as well to which type of grade you should select. Standard austenitic grades from the core and supra range are very good for general use, as we have said here. They have excellent formability, excellent corrosion resistance. We have 304, 316, or our leaner version 316 plus, which is nitrogen alloyed as well. You can use it in a range from cryogenic temperature up to very high temperature approaching 550, or with special version for high temperature use slightly higher than that as well. And you can go down to cryogenic temperature, and now lately using you want to store hydrogen as well, and then you go down to very low temperature. There you're typically using more stable austenitic grade like 316 with high nickel content, or the nitrogen alloyed 316 version, very stable grade that can be used at those very low temperature there for cryogenic vessels. If we step up to the higher temperature range, where you need to consider oxidation at high temperature and creep strength, we have very specialized alloys as well. We call the Therma 2MA, or the more common Therma 310S, or you can have special version of 3LN, Therma 4910, that can be used up to temperature above 1000 degrees C in certain cases as well. Then we have the Ultra for very harsh environment. Of course, they can be used at the temperature range from cryogenic up to very high temperature as well. Then we have the Duplex grade, and there comes the critical thing here. Duplex will be used temperature at about -40 degrees C or slightly below that, and up to temperature about 250 or approaching 300 degrees C, depending on how long exposure time you have. So that is a limitation for the Duplex grade. Then you have the temporal austenitic grades. They can be used in a wider temperature range than the Duplex, but not as wide as the standard austenitic grades. And then we have ferritic grades. They can be used a slightly wider range than the Duplex, and also the martensitic grade, when you need high wear resistance, can also be used in a slightly wider temperature range than the Duplex. So the Duplex and the ferritics are those that you really need to consider the temperature range both at the highest side and at the sub-zero temperature side as well. Duplex can be used at slightly lower temperature than ferritic or martensitic if we're looking at low temperature side there. So shortly about a few applications which are perhaps less common. Considering a fuel tank, quite often they are plastic for a car, but considering austenitic stainless steel, which has a very good formability, and in this case, using a core 301, you have a very good formability of this grade. But what is good with this grade is if you're using hydroforming, you can actually blow up with a high pressure water on the material. You have a very good formability, but also when you stretch the material, you will also increase the strength of it. So going from a relatively low strength, good formability, we blow it up, we can actually increase the strength a lot, and you will actually reach the Forta range having proof strength above 1,000 MPa. So utilize the good formability and let's say convert it into strength, and you can have a very thin structure, very complex shape of a fuel tank for a car by using the good properties of the 301 type of grade. Another for the Supra range for 316 is to use it for facades. We have a lot of application for that. Also more, let's say, well-known building. Here we have a building in LA. The reason why I selected this one is it's close to the sea. It has been here for over 30 years. It's still in a very good condition, and that is the reason why using Duplex. It's about the aesthetics, but it's also about the long-lasting properties, the durable surface. Of course, if you clean it regularly, you can have an even better performance of it. And of course, with the very famous Chrysler building, has been there for even longer period of time with perfect condition of the surfaces there. For the cool side, for cryogenic vessel, in this case, using 304 LN for rebars. So for cryogenic use, you need to use stainless steel. Of course, you can also use stainless steel tanks for cryogenic use as well, with very good performance. So of course, very low temperature, and you need to have austenitic grade to resist this environment. Going up to higher temperature, we're talking about heat treatment basket. SKF is a Swedish producer of roller bearings. They need to heat treat their bearings, and that is done in furnaces with 900 degrees C. Until now, they have used carbon steel for the baskets for the heat treatment, but using carbon steel, the heat treatment only lasts about 3 to 5 cycles of heat treatment, and after 10 to 15 cycles of heat treatment, they need to scrap the basket, and of course that is not a good sustainable solution here. So they were considering using stainless steel instead and going for our Therma 253 MA, and they have used this as a prototype, and they can see that this can run for more than 300 cycles. So that means a 50 times longer service life than using carbon steel. So also from a life cycle time perspective, of course, it's a more expensive material, but you can get a much longer service life from it. Then we come to the Forta, and a very interesting application to use the Duplex grades for bridges. So what we have here is to replace a 30-year-old deteriorated reinforced concrete bridge. This is in an area, a resort area, so they wanted to find a very aesthetic, nice bridge solution. It's very close to the Mediterranean Sea, very high level of chlorides, a very corrosive environment. So what they finally decided was to go for a Duplex 2205, which combined a good corrosion resistance with high strength. What we have done here is also to look at this bridge after 10 years of use. Here you have some facts of it. 45-meter long. It's a road bridge. You can run over it with vehicles as well. Designed by the Eurocode, that is the European structural design standard. Thicknesses from 10 to 25 millimeter, 130 ton of material used. So 2015, we actually went for an inspection because, of course, we're promoting the long-lasting performance of stainless steel, that you don't need to recode it like you have on the carbon steel. So let's have a look at it after 15 years. So there's a lot of chlorides in this area where they have this bridge in the channel, that's for sure. And if you will use the ISO classification, it's a C5 environment. So we are at the most corrosive environment. When we expected this, we saw that we were not using the ISO standard, but the Eurocode standard, and there they're using corrosion resistance classes. So it was categorized as a resistance class as 4, and it's up to 5 is the highest, most severe class where you need the highest corrosion resistant material. So on the upper side, where you have a very good the surface is rainwash, so it's regularly clean there. 2205 is needed, and that is what's selected. The condition after 10 years, you see it's a very good condition there. If you look on the bridge deck from the below instead, this is a more severe environment because no rain washing of the deck underneath there. So the corrosion resistance class is 5 here, so it's higher than on the upper deck there. But the 2205 is used here, and it's in a very good condition. Some staining from the cement product, but otherwise perfect condition. However, if we're looking at some vehicle barriers here along the road here, they were actually selected in 316 not to use the Duplex. And the corrosion resistance class here is 4, but we can see it's heavily stained here after 10 years. So they should have selected Duplex here as well, the Duplex 2205, to have a good performance here, because here you can see some discoloration clearly. Very shortly, typically tanks for breweries, wine tanks or for beverage are used. They're using austenitic grade like 304, but why not use a ferritic grades like the 4622? That's a high chromium grade where you can have a similar corrosion resistance. And what is very interesting using ferritic grades instead of austenitic grades is that typically on beverage process tanks, you're using some kind of a cooling jacket, or in this case, dimple jacket, to control the temperature within your tank. So you want to have efficient cooling, but of course on the outside, you want to minimize the heat exchange with the ambient air on the outside. And that can be quite hot if you are in India or if you are close to the Mediterranean Sea in Europe. And on the inside, you want to have the coolant, you want to have the maximize your heat exchange between the coolant and the liquid. And what's very interesting here, if we consider the thermal conductivity, which is very important here, how you conduct the heat between the dimple jacket, the heat exchanger, and to cool down the liquid, you need to consider the thermal conductivity. Of course, if you have a higher strength, you can also utilize that potentially and reduce the thickness. That also would improve the heat transfer. But using a ferritic steel instead of an austenitic 304, you can potentially actually increase the heat transfer efficiency with 40%, thanks to the higher thermal conductivity of a ferritic grade compared to an austenitic grade. So that is a quite interesting application that is actually now evaluated as well. For kitchen knives, of course, using Martin City grade is what you want to do. We have a very interesting grade 4116, which has both high corrosion resistance and high hardness and edge, respectively, better performance when more common for 20 type of grade there. So that is something that is interesting of using martensitic grade for kitchen knives. Now we are run out of time, and once again we haven't had time due to all the connectivity problem go into storage and handling of stainless steel. Very shortly, storage and handling of stainless steel, it's very much about common sense. You have to make sure avoid contamination of mild steel. Make sure you separate stainless steel manufacture and fabrication from carbon steel production, because otherwise you contaminate the surface of the stainless steel, and that can initiate staining on the surface. Of course, also avoid contamination with oil, grease, and paint, but that also can affect the performance of the surface of the stainless steel, and also to avoid contamination with copper, brass, and zinc, because that can cause liquid metal embrittlement and crack of the steel. If you have a plastic coating, as you see here, keep it as long as possible, because that can protect the surface also during, some kind of a cutting operations as well, and even fabrication operations that will protect the surface. Use stainless steel tool if possible. Use clean lifting device. Use coated chains and wires. Use coated forklift forks, and never use carbon steel tools when handling stainless steel. This is our traces when you have used carbon steel that will come on the stainless steel, and it looks like it has corroded, but it's actually contamination there. And also unsuitable marking, remove it, because otherwise you can have crevice corrosion underneath stickers, for instance. So store it flat or in racks. As we said, support the whole place so you don't get deformations. Lift carefully, be very careful, protect the surface, avoid contamination. It should look like this. Of course, even better if you can protect the surface, not like this, because then you will end up with problems. So be very careful how you treat your stainless steel, and you will have good properties from them. Now I think I will stop here, and hopefully you have learned some here, even though I've rushed through it to some extent here. So okay, thank you very much from my side here.
Rohit, we can't hear you.
Now, is it better now?
It is clear now.
Yeah. So thanks, Clis, and you finished well within time, and now we have time for question and answers, and I'll request Deepak to take it forward from here.
Thank you, Rohit. We have one interesting question. This is related to how temper of grades are classified here. I think this is related to our initial slides. And a related issue has been informed. It's related to 301 Allen grade, where they are doing some cold forming and find that material gets corroded on thinning areas. So wanted to know whether passive layer has gone, or how it can be rectified. So class, I can take up this question. I can answer this. Thank you. So it depends upon many aspects. As we read through the data that you have provided, in stainless steel, the passive layer doesn't go like that just during the process. It's a self-healing layer. That is one part. Second thing, if you are facing some issue in a grade, see, let me tell you, like when you're talking about any grade, say 301 LN you have mentioned, which is 4318. There are many related aspects, starting from selection of the trans elements, how you are producing the grade, which composition you are using. See, standards are just for reference. Like for 301 LN, it says 6 to 8% nickel, 16 to 8 chromium, and 0.07 to 0.2% nitrogen. But how you are optimizing that, it depends upon the expertise and experience of the mill, that for a particular application, how do you select the right composition? And when you are processing that material to the temper rolled conditions, like to achieve a very high mechanical strength from 500 to 900 megapascal, how you are optimizing your processes to reach the desired strength level to reach your application. That is one part of it. But as you have mentioned that you are still facing the problem, and some passive layers are gone, it's not like that. Probably due to the corrosion issue in the external environment or related aspects, we think that you should look for grades which can give you higher strength and has a metallurgy which can withstand higher corrosion also. If you talk about the corrosion resistance, which you have mentioned, like for 301 LN, normally the PREN number is around 20, because you're talking about corrosion. But if you talk about the lean duplex LDX 2101, which is 26 PREN, which means you get a higher corrosion resistance and you get the higher strength also. That's the brief answer to your question. We request you please send us your details and the detailed problem with some pictures, and we can discuss it offline. And then we will be able to give you good solution and probably work along with you to find and optimize your the problems you are facing. So that's my answer. And next question, I am posting it to you, class. Mr. Naveen has written, I need some tips or solution how we can avoid corrosion after gas nitriding followed by surface machining in the automobile components.
Yeah, that is a quite tricky question actually to answer this straight away like this. I think that is something we can consider separately. I cannot give a good answer to that question here.
Yes, I think that is one general issue, because normally the questions need to be looked at with much depth and suiting the end application. So we request you please send us an email, and we will be happy to discuss it in large and detail with you. We have one question from Mr. Shiva. He wanted to know that how can he get the corrosion handbook. So class has shown you that you can find most of the details on our website autocompu.com, some corrosion table and data. But still, if in case you are looking for the hard copy, do write to us and we'll be happy to send a corrosion handbook to you. We don't have a soft copy, but we'll send you a hard copy on that. So another question which we have is, this is related to the case study which class you have shown about the water tanks using the higher metallurgy. I think class is again some problem. Are you there, class?
No, I'm here. I was
okay, perfect.
The video was off there for a while there.
Okay, no problem.
I had a bad connectivity.
So this is related to the storage water tank. And the issue is because of the external corrosive environment, they are facing some issues with the standard 304. So what are your possible grades you can suggest for that?
I would clearly say the experience I have in most cases for water tanks, the lean duplex Forta LDX 2101 is a very good alternative to using 304, because you have the corrosion resistance approaching that of the type 316, and at the same time a higher strength. So potentially you can reduce or but also have a higher corrosion resistance. So to have a very clean duplex LX 2101, I would say in many cases is a good solution. Or if it's you need even higher corrosion resistance, you can go duplex or you can look at if you want to have an austenitic alternative, could be the Supra 316 Plus as well.
Okay. We have another question. This is related to the Gala Bridge Spain application, and question is, okay, I need some, okay, this is done. What are post fabrication cleaning methods employed? This is for the bridge application that is shown.
Yeah, you mean the post welding treatment?
Yeah, he has mentioned post fabrication cleaning. Probably this is related to the surface and all that.
Yeah, that is a very good question, and there are a few options there. Normally, in a location like that, you will not do perhaps a pickling operation of as a post-weld heat treatment, because from the environmental point of view, tricky to do that. What you can do then is to do a mechanical cleaning with brushing of the welds. Using a slightly rougher first and then go for a finer brush. But of course, that can reduce the corrosion resistance to some extent, as you have to be very careful there to go to a smoother cleaning and make sure you remove the oxide layer from the welding. Also going a bit away from the actual weld seam as well to make sure you clean the surface there. Another option is to use a glass bead blast cleaning as well, but from an environmental point of view, that can be difficult as well. And then thirdly, of course, it's possible to use some kind of a pickling paste, but the aesthetic aspect is important here. And then, of course, some kind of a bead blast cleaning would be the best, perhaps, to make sure you're getting a good, even aesthetic surface of the bridge.
Okay, thank you, Clash. Another question I have from Mr. Vijay. What is the preferred maximum sulfur content in 316L for good weldability?
I'm not sure. I cannot answer that from the top of my head. Do you remember that, Deepak? Otherwise, we can come back on that one.
Yeah, we'll come back to it. I don't remember exactly what is the maximum sulfur. We will revert back to you, Mr. Singh. These are the questions we have for today, and if anyone has any additional question, please do write to us and we'll be happy to answer. Thank you. And another question that has just popped up: why 2D finish of strip is preferred over 2B for metal tubing for longer length, that is about 15,000 feet? This is something new. Actually, see, the difference between 2D and 2B finishes, both are cold rolled. 2B means you are cold rolling, annealing, and pickling the material. And if you are going for an additional process of skin passing, then the surface is called 2B finish, which means that you are reducing the RA value. So one thing is that it doesn't matter if you are talking about the process pipes, if you're talking about whether it is 2D or 2B, it doesn't matter. But if in case you are going to polish the material, then definitely there are different aspects that how you are polishing. If you want to use a very fine polish or like that, then 2B will give you a better finish much faster. But if in case you are going to paint this tube or do something on the edges, then maybe 2D or 2E finish will be better because of the bit higher RA value, because then you have some higher RA where the paint can stick up. So I have never heard about that people are preferring. People always ask for to be finished. But like that, it doesn't matter whether it is 6 feet or 15,000 feet. They are more or less same. Another question, Mr. Shikhar. Which grade of stainless steel can be used in mobile tower application? Okay, Shikhar, it depends upon where you want to install the tower. So, if you are talking about some coastal areas, then surely duplex are the right choice because normal 316 and 304 will not sustain because of the chloride environment. But if you are talking about North India, metro cities, you may not have the chlorides, but you have a lot of carbonation because of the vehicles running, then you need to select the right grade over there. And again, it depends upon the whether it is on the main city or highways, how is the soil content, is there any moisture in the soil or minerals, so you need to select the material there. Like giving an example, we have seen some applications even in Nepal or maybe Northeast India where you can say the water is very clean, but then you have minerals underground which affect the properties of the steel. So yes, location and environment matters a lot. We can help you if you tell us the location and some properties will help you that. Well, that's all we have for today. Over to you, Rohit.
Thank you, Deepak. I hope all the questions have been answered, and I'll request if anybody has any further question, they want deeper insight into this subject, then please write to us at nisda@gmail.com. You can directly contact to Autokumpu also, which Deepak has provided and Mr. Seri has provided the IDs. You have Nickel Institute also. You can visit to the Nickel Institute website and see there are immense technical information already available at Nickel Institute website. Or you can also visit the ISDA website at www.stainlessindia.org to ask further questions as well as find some technical information. So with this, first I would like to thank all the participants who have taken time out of their busy schedule and have been a part of this educational series. Though it was a long series over few months, but it does not end here. We'll come back, design further educational series, and go into specific areas to help you out with your questions and provide education in this area. Once again, I'd like to thank first. I would like to thank Tiger Strand for being a part of this series. Almost in all the 5 series, he has been instrumental there. To Mr. Rajiv Seri and Deepak for such a wonderful support, technical support as well as logistic support from Autokumpu. To Zorg, who has been key to this series, supporting through Nickel Institute, and to our president, Mr. Pahuja, and in the back, Jocelyn, George, and Rahul, who has been looking after this software and nuances of this WebEx platform. So with this, I would like to thank everyone once again and end the session. And we look forward to see you in our next webinar in emerging market, which is on high strength structural stainless steels. So you will be given information on that through mail and other means of WhatsApp and other social media means. Thank you very much. Thank you all.
Thank you
as well.
Thank you. Bye bye.